So guys, we will continue our lecture on wave mechanical model of atom, right? So we have reached till this point where we were discussing in previous video lecture that the wave mechanical model of atom did not contradicted this Heisenberg's uncertainty principle because it gave us the concept of orbital, right? And if you remember, in Bohr's model of atom there is a concept of orbit, right? Orbit is a well-defined path, right? When we say well-defined path, to define a path we need to know the position and velocity at the same time, right? But as per Heisenberg's principle, position and velocity cannot be calculated at the same time, right? So the concept of orbits in Bohr's model contradicted your Heisenberg's uncertainty principle, which lead to its failure, right? But we have seen here that when we solved Scrodinger wave equation, it gave us a wave function psi, right? And this psi is nothing but your orbital, right? This psi is nothing but your orbital, right? And using the value of psi, what we did, we calculated the square of psi, right? The square of psi, right, which is a wave function, gave us the probability of finding an electron, right? So using psi square at different points, we constructed this electron cloud, right? And this electron cloud shows the probability of finding an electron around the nucleus, right? So what we call this electron cloud is where you find the electron in an orbital, where there is maximum probability of finding an electron, right, in an atom. We call this as orbital, right? So here in this orbital you can see there is no well-defined path. The electron can be here, can be here, can be here. So there is probability of finding an electron. There may be high chance of finding an electron near the nucleus, right? But there is chance of finding the electron away from the nucleus also. So we say there is no defined boundary of an orbital or this electron cloud, because the probability of finding an electron, that is this psi square, is never zero, right? So there is no well-defined boundary, and it does not give any definite path like that of an orbit in Bohr's model, right? So it did not contradicted Heisenberg's principle. And if we talk about the other drawback, the Bohr model did not included the dual nature of matter. But since the beginning of this lecture we are seeing that we are using quantum mechanics, right, to deduce to know about the structure of atom, where we find the value of E and psi, right? We solved Scrodinger wave equation H psi E psi to get the value of E and psi, right? So using the value of E we got orbital, right? And the value of E gave us the energy levels, right, which are quantized energy levels. We say by quantized we mean that they can have only certain specific values, right? So this quantum mechanics, we have applied quantum mechanics here, which takes into account the wave nature of electrons as well, right? So wave nature of electron or the dual nature is included in wave mechanical model. So these two contradictions are removed, right? Now the most important thing here is that wave mechanical model gave us the concept of orbital, right? And the orbital, let's learn more about orbital. Since we said that this electron is a wave, right? Since electron is a wave, electrons can have multiple wave functions, right? It can have multiple psi, the value of psi. Since it can have multiple wave functions, and we say that this psi represents orbital, right, which is a wave function. Since there are multiple wave functions, so we have multiple orbitals in an atom, right? And so now we know there are multiple orbitals because of multiple values of psi, right? And the other thing is that since we said that this is the electron cloud, right, and we called this electron cloud as orbital, where there is maximum probability of finding an electron. right, the kind of shape it makes, right, this is the shape of orbital. This, if we talk about this shape, this is for this is a spherical orbital, right? Similarly, the probability, if we find this probability of finding an electron may take different shapes, right? It's here like this, so it may be like this, right, where the probability of finding an electron is maximum, right? We are seeing this probability in 3 dimensions, right? So we may go like this, right, we may go like this, right, like this, like this, like this. So depending on the shape of orbital will tell you the probability of finding an electron in 3 dimensions, right? That's what it gave you, that's what it tells you. And there is one more thing, that since we are talking about hydrogen atom, so this orbital, s orbital, can contain only 1 electron, right? And in maximum, one orbital can contain maximum of 2 electrons, not more than 2 electrons, right? Which is the basis of, we'll see in next video lecture, electronic configuration, right? One orbital, when you will write down electronic configuration of atom, right, what you do is you fill up electrons in orbitals, right? So any orbital, any s, p, d, f orbital, we'll learn that in next video lecture, can contain maximum of 2 electrons, right? And these orbitals will have different energy, right? So we are almost done with this. Now what we need to see here is, another important thing is, since we have solved here Scrodinger wave equation, we solved Scrodinger wave equation for a single electron atom, right, which is your hydrogen atom. So if you will solve Scrodinger wave equation for multi-electron atoms, or let's say first if we solve Scrodinger equation for hydrogen and hydrogen-like atoms. Hydrogen-like atoms are like helium plus, right? It's those atoms or ions, those that contains 1 electron in their orbit, right? Those are your hydrogen-like atoms. So Scrodinger wave equation, since we solve Scrodinger wave equation to get the value of E and psi, right, to define the structure of atom, right? So Scrodinger wave equation can be solved exactly for those atoms that contains only 1 electron, right? But when we try to solve Scrodinger wave equation for multi-electron atoms, for example, if you try to solve Scrodinger wave equation for helium atom that has 2 electrons, right? If you remember, in the beginning I said that we construct this H psi, here you have, this is the Scrodinger equation, right? We construct Hamiltonian operator, right, from energy, right, energy of the system. So if you take multi-electron atom, the energy of the system, right, will include the repulsion potential, right, repulsive forces between the electrons, right, because you have 2 electrons now. So this energy will include repulsion between those electrons, because this is the total energy of the system. That includes, in the beginning I said that this energy is attractive forces between electrons and nuclei, and repulsive forces between nuclei and between electrons. So in case of multi-electron atoms, we have one component in this, that is due to the repulsion between the electrons, right? So when you try to solve Scrodinger wave equation for multi-electron atoms, it includes these repulsive forces that is acting between the energy due to these repulsive forces that is acting in multi-electron atoms. So when you try to solve Scrodinger wave equation for multi-electron atoms, the equation becomes very complicated, right? So you cannot solve Scrodinger wave equation for multi-electron atoms exactly, right? Scrodinger wave equation can be solved exactly only for hydrogen atom that contains 1 electron. It cannot be solved exactly for multi-electron atoms because the equation will become very complicated, right? It cannot be solved. So what you do is, right, what you do in order to solve, what you don't use Scrodinger wave equation, you use approximation methods, right, for multi-electron atoms. This is not in your syllabus, it is in higher classes, right? So we are not going much deep into that. Just remember that Scrodinger wave equation can be solved exactly for hydrogen atom. It cannot be solved for multi-electron atoms because of the repulsion between the electrons, and due to these repulsion between the electrons, the Scrodinger wave equation will become complicated, which cannot be solved exactly, right? Now, since it gave us the concept of orbitals, right, it gave us the concept of orbital, let's point out some differences. And before this there was a concept of orbits in Bohr's model of atom, right? So this is in Bohr's model. Now we have orbital, right? Let's point out some differences. This orbital, this is a planar path in one plane, right? 2 dimensions. So this is a planar orbit. It has planar path, right? But if you talk about orbital we said is psi, right? And the value of psi depends on x, y and z axis in 3 dimensions, right? So this orbital which depends on the value of psi is in 3 dimensions, right? Orbital is orbital is the probability of finding the electron in 3 dimensions, right? So this is in 3 dimensions, right? The other point of differences are, we know that all orbits are circular, right? We talked about, I just told you that the probability of when we find the probability of an electron, right, around the nucleus, like here we got this electron cloud, like this is your spherical shape, this is your s orbital. But for other orbitals, since we have multiple values of psi, multiple wave functions, so we have multiple orbitals, right? So if you try to find the probability of electrons, right, in those orbitals, you will get different shapes, right? So orbitals can be of various shapes, like later you will learn sp, d, f orbitals, right? All these have different shapes. Now orbits are always circular, right? And the maximum electrons, like I said, an orbital can contain maximum of 2 electrons. If you remember, we are doing it from smaller classes, junior classes. Maximum number of electrons in an orbit is given by formula 2n square, where n is the energy level, right? So these are the major differences in orbit and orbitals, right? And the important thing that we got to know in this wave mechanical model is the concept of orbital, right? And we would be using this in your electronic configuration of elements, right, where we fill electrons in various orbitals, s, p, d, f, right? So I hope all this is clear to you. And just remember Scrodinger wave equation, right? And one more thing, you have something you may find in your books as eigenvalues and eigen functions. Like I said in the beginning, that the Scrodinger wave equation can be solved, right, for the value of E and psi, right? We solve Scrodinger equation for E and psi, right? So the values of E energy are called eigenvalues, right? And the corresponding value of psi is your eigen functions. These are wave functions, right? So these are your eigen functions, right? For every energy level you have associated wave function, right? This energy level, the value of this energy level is your eigenvalue, right? And the associated wave function is your eigen function, right? And remember that this wave function is 3-dimensional. Its value depends on the coordinate axis, right? And using this psi, the value of psi, we will find psi square, which represents the probability of finding an electron, right? If you find psi square at various points around the nucleus, what you get is an electron cloud that is defined as an orbital, right? So there are some features. Let's just summarize the features here, what we have learnt. the features of quantum mechanical model. Right. So the features of quantum mechanical model, the first feature is we solved Scrodinger equation for E and psi, right? So it gave the value of E gave various energy levels, and these energy levels are quantized. When we say quantized, we mean they have certain specific values, right? They cannot have any value, but they have certain specific values, right? And we also said that both the exact position and velocity of an electron in an atom cannot be determined simultaneously when we talked about the contradiction statement, or with Heisenberg's principle, the path of an electron in an atom therefore can never be determined accurately, right? That is why the second is position and velocity cannot be determined simultaneously, right? What we talk in wave mechanical model always about the probability of finding an electron. So there is no definite path or position, right, of an electron that we have fixed around the nucleus. So what we talk about is the probability of finding an electron, around the nucleus, right? Then we talked about psi, right? We solved Scrodinger equation for psi. And what is psi? Psi is, we looked that psi is an atomic orbital, right? So atomic orbital is the wave function psi for an electron in an atom. So atomic orbital, if you want to define from this explanation, atomic orbital is wave function psi, right, in an atom, right? And the other important point is an orbital cannot contain more than 2 electrons. We have already discussed all this, right? In a multi-electron atom, electrons are filled in various orbitals in the increasing energy levels. And the probability of finding an electron at any point within an atom is proportional to the square root of your orbital wave function. This we have already discussed, that probability of finding an electron is given by square of your orbital wave function, or the square of wave function, right? And if you construct the probability around the nucleus, what you get is an orbital, right? So that is why we say that psi is an orbital, because if using this psi using this psi only we are finding psi square, right? That gives us the probability of finding an electron, and using this psi square only we are constructing what we call as atomic orbital, right? So I hope all these points are clear to you, right? And these contradictions, how it got removed, and the concept of orbital is important. And Scrodinger wave equation, we solve it for H and psi. Why we cannot solve it exactly for multi-electron atoms? Because the equation goes complicated, which cannot be solved exactly. It can only be solved for single electron atom like hydrogen. I hope all this is clear to you. Thanks.